coming to table and tabloid values, we have three types of table that we will look into. Out of this, t table and chi-square table are used for hypothesis testing, and z table, which is also used for hypothesis testing, is also called as unit normal table. You can use this unit normal table to, or all of these three tables, to calculate the tabloid values that we have talked about a lot in hypothesis testing. So let's get into this. First of all, we have to understand normal distribution curve and some notations. So in normal distribution curve, let's say this is the z. It can be anything other than mean, because it is obviously a little bit left from the center. So this portion which occupies majority of the curve, it is known as body, and notation used is b. Same way, this portion, now for this z, this will be body, right? And other portion that is left behind, that is shorter, it is known as tail of the normal distribution curve. It is known as tail of the normal distribution curve. We can have a situation where we are given the mean as well as a particular z value that is not mean. Now area in between is noted as c. So we have, it is noted as t. So now we have three notations: b, c, which is for tail, and d. Now we will see how a z table looks, which is more commonly called as unit normal table. Now the use of z table is basically to convert a z value into a p value. You will be given a z value in your question, or you will calculate it yourself, and now you will have to convert it into p value to look whether it is less than 0.05 or more than 0.05, and based on that you can assign significance to the test. Now, so this we have discussed, right? C and B. So we have three portions in the table, four portions actually. One is for Z, and other three are for B, C and D, which we already discussed as body, tail, and portion between mean and Z. So you have a particular Z value, let's say 0.09. You can find out all three portions for this. So let's take an example and we'll understand this. Okay. So let's say you have a normal distribution curve, and you are given that there is a z value 1.85. Now you want to identify what is the probability that a particular value will lie in this area or C area. Now for that you will first locate a z value of 1.85. This is the value, and now you will look in the C portion, which is 0.0322. So probability of a value coming in this portion will be 0.0322 or 3.2%. Okay. Same way you can calculate it for B. Now there is another use of this unit normal table that you must be very familiar with, and which we are going to discuss now is, okay, so you have a problem maybe during your hypothesis testing. You are given the alpha for a particular test is given as 5%. Now you have identified every variables and you have calculated your z value. Now you want to compare it with a tabloid value of c that corresponds to the alpha value of 5%. Okay, so you have alpha of 5%. Now for this, if you watched earlier video, you remember that alpha is divided into two parts, alpha 2, alpha 2. So each of this will be 2.5%. Remember, because it is a two-tailed test, you have to divide total alpha into two alphas, alpha by 2, alpha by 2, and they will be rejection areas. Now if I want to put it in another way, I can say that probability of a value coming in this area is 0.025. Same for this. So we are asked to find out these two values, which will be similar but different notations. Okay, so it is called z alpha by 2, which is also known as z tabloid value. Now, so we will have to find 0.025 in the tail portion of the table. So in C portion we will find 0.025, here it is, and for that we will look into Z values, which is 1.96. so this Z will be 1.96. okay, please don't make a mistake of looking for please don't make a mistake of looking for 0.05. that will give you a false result. That will give you a result for alpha for 10%, because in two-tailed test, which is most of the time case in Z test, you have two-tailed values. So you have to divide alpha into two parts, and then only you can calculate the corresponding Z value or Z tabloid value. Okay, moving on, T table. Now, as we have already seen many times, T tests are one-tailed or two-tailed. Now, for one-tailed test, alpha is alpha only, and for two-tailed, alpha is divided by alpha by 2 for each portion. Here it is alpha, here it is alpha by 2, alpha by 2. Okay, so if you are given, now first of all let's take a look at this table. So see, one-tailed, two-tailed. Now if you are given that alpha for a particular test is 0.05 and you have to find out both one-tailed and two-tailed values or T tabloid values, then you will simply look here. You have, for example, say degree of freedom 1, then you will simply look here for one-tailed 0.05, and for two-tailed you will look here. Okay, and that will give you corresponding values. Now if you see, all the values for one-tailed test are multiplied by 2 to get the values for two-tailed test, and that is very explanatory, because here it is alpha by 2 that we are calculating. Okay, next is chi-square table. I have already discussed this while I explained about the chi-square test, but we will take a look at it again. So let's say, so this is the notation for chi-square for tabloid value, where x is alpha, y is degrees of freedom. Now here I forgot to mention, for T tabloid also the notation is same, 0.05 on x axis and degrees of freedom on y axis. This will give you T tabloid values. Now I might call it T tabloid values, and some people might call it T table values or ideal values, or this might be referred to as simply a T. So do not confuse it. I will call it T tabloid throughout the video. You refer to it as your book says. So this we have seen already. Okay, so for example, let's say it was 0.05 given in question and degrees of freedom for 2. So for this, on y axis 2, on x axis 0.05, it will be 5.99. Simple. Okay, thank you.